Courtney, and we are reading in our science book on page 231, section 8.6. And this is a very long chapter, so just bear with me here, okay? The fury of storms. Imagine that while you are playing outside on a warm summer day, you hear a faint rumble far off in the distance. Looking in the direction of the noise, you see a small patch of darkness very low on the horizon. As time passes, the darkness spreads, blocking out the afternoon sun, and the rumbles become louder and more frequent. A few tattered, dirty clouds pass low overhead. Trees sway back and forth in strong gusts of cold wind. Blinding flashes of jagged streaks of light flicker among the thick masses of black clouds. When a few large drops of rain splatter on the ground, you decide that it is time for you to go indoors. You make a mad dash for shelter just as the clouds release their floods of rain. Once inside, you can watch with fascination as the storm rages. The fierce wind howls and shrieks around the corners of your house, drives sheets of rain and spray sideways across the lawn, and lashes tree branches into violent twistings. Ear-splitting crashes and deafening booms explode all around you. Then, almost as quickly as it came, the storm passes on, and the sun peeks out from a break in the clouds. The hard-working cumulonimbus cloud. Most of us have experienced a thunderstorm just like the one just described. A thunderstorm is produced by the cumulonimbus cloud, also called the thunderhead. A giant cumulonimbus cloud is an engine of tremendous power. Like other engines, the thunderhead works to do specific jobs. One of these jobs is to water the earth. Another is to help cool the Earth's surface by carrying trapped heat into the upper atmosphere, making it easier for the heat to escape into space. Every engine has its design, and the thunderhead is no exception. This cloud is not a large mass of peacefully floating water droplets as other clouds. Deep inside the thunderhead, an incredible amount of activity takes place as the cloud labors to do its tasks. Gusting winds, hailstones, lightning bolts, tornado funnels. These are the visible result of the cloud's inner workings. In this section, we are going to probe into the dark and mysterious depths of the cumulonimbus cloud. Growing up in a hurry. Where does this mighty thunderhead come from? At first, it may be hard to believe that a cumulonimbus cloud is actually related to a tiny, fluffy cumulus cloud that you see on a hot day. Both of these clouds form in the same way, by solar heating. The cumulonimbus is simply an overgrown version of the smaller cumulus cloud. Ordinary, fair-weather cumulus clouds are small and short-lived. They melt into nothing as the wind carries them away from their source of warm weather on the ground. But if the temperature of the air near the ground is warm enough and the humidity is high enough, these small, puffy clouds may eventually grow into huge cloud giants. On a summer morning, small cumulus clouds form when bubbles of warm air rise over hot areas of land. These early morning clouds quickly evaporate in the cooler, drier upper air. By releasing their warmth and moisture into the upper air, they allow clouds forming later in the day to grow to higher levels. These clouds, in turn, prepare the air for even taller cumulus clouds. By late afternoon, cumulonimbus clouds form. The anatomy of a full-grown cumulonimbus. Is there a limit to how high clouds can grow? The tallest cumulonimbus clouds reach all the way to the very top of the troposphere. Remember that the troposphere, the boundary between the troposphere and the tropopause. Remember that the tropopause, the boundary between the troposphere and the stratosphere, is the location of a temperature inversion. This inversion places a cap on the growth of clouds. Warm air rises upward from the ground, is kept from rising any further by warmer air in the stratosphere above. Unable to ascend, the rising air spreads out over a wide area, forming a broad, flat top on the cloud. The top area looks wispy because at such high levels, it is made out of ice crystals instead of water droplets. Upper level winds blow the wispy, flat top far out in front of the rest of the cloud, giving the cumulonimbus the shape of a gigantic anvil, which is a metal block on which blacksmiths pound hot iron. Meteorologists say that the cloud has an anvil top. The cloud's anvil shape, towering far above into the blue sky, can be seen only at a great distance. The cloud is so huge that up close all we can see is the broad bottom of the cloud. The base, up to 50 miles wide, covers the entire sky with its darkness. To someone looking at the cloud from far away, the upward parts of the cloud appear a brilliant white, because the small cloud particles reflect the light of the sun. But down below, the bottom part of the cloud is very dark, because the sunlight cannot filter through the cloud's huge bulk. A fully developed cumulonimbus cloud is fueled by updrafts of warm air rising from the ground into the cloud. As the cloud travels over the land, it draws warm air into it from the ground out in front, and then carries it upward through the cloud at tremendous speeds, perhaps as much as 100 miles per hour. In other areas of the cloud, strong air currents rush downward toward the ground. Raindrops falling through the cloud draw these powerful downdrafts along with them. The downdrafts strike the ground and spread out in front of the storm, causing the sudden increase of wind you notice as the storm approaches. A stormy brand of weather. Hail. An unusual kind of precipitation called hail forms only when tall thunderheads with powerful updrafts. Each hailstone begins as a small piece of ice caught in the updraft of a cumulonimbus cloud. The updraft throws the hail very high up into the anvil top of the cloud. After being tossed out of the updraft, the hailstone begins to fall back to the ground. As it falls, it attracts water droplets in the cloud and collects a layer of water that freezes on its surface. But before the hailstone can make it all the way to the ground, the updraft again catches it and hurls it back up to the top of the cloud. The hailstone rides up and down several times, adding additional layers of ice on top on each round trip, until it is too large and heavy to be kept in the air by the updraft, and it falls to the ground. It is so large and falls so rapidly that it is still frozen solid when it reaches the earth. The stronger the updraft of the storm, the larger the hailstone will be. The largest hailstone reported, weighing almost 2 pounds and measuring 6 inches across, was about the size of a small cantaloupe. Lightning. At one time or another, you probably have felt a shock as you touched a metal doorknob or with your finger on a cold, dry day. If you looked closely, you may have seen a small blue spark jump between your finger and the doorknob. A buildup of opposite electrical charges, negative on your finger and positive on the doorknob, cause an electric current to flow between the oppositely charged bodies. The electric current allowed the charges to be balanced out. You can think of lightning as a huge spark. Electric current flows between oppositely charged areas in the atmosphere in the same way that the spark jumps from your finger to a doorknob. Lightning is produced only by very tall clouds, such as the cumulonimbus. In these tall clouds, opposite electrical charges build up with a strong positive charge throughout the top portion of the cloud and a strong negative charge near the base of the cloud. The powerful negative charge in the bottom of the cloud attracts a strong positive charge in the earth below it, and the positive charge follows the cloud like a shadow as it moves over the ground. The positive charge runs up and accumulates in the tallest objects and it can find in its efforts to get as close as possible to the negative charge in the cloud above. The opposite charge in the cloud and ground build up until they are able to bridge the gap of air between them. A giant bolt of electric current stabs through the air between the opposite charges, balancing them out. Actually, the lightning bolt you see for a split second is a series of events taking place at high speeds. First, a step leader zigzags downward from the cloud. The step leader is a thin channel of charged air through which the lightning bolt can travel. When the step leader nears the ground, a burst of positive current from the ground shoots upward to meet it and flows through the channel to the cloud above. Then, negative charge drains from the cloud to the ground. Repeated upward and downward flows of current through the same channel may take place, causing the lightning bolt to flicker. The whole process lasts only about 1/2 second. When the powerful current of lightning bolt flows through its channel of air, it heats the air to a temperature of 54,000 degrees Fahrenheit, 5 times hotter than the surface of the sun. The superheated air expands rapidly, causing sound waves we hear as thunder. Because lightning travels faster than sound, you can calculate how far away a lightning flash is by counting the number of seconds between the time you see the flash and hear the thunder. Every 5 seconds is equivalent to 1 mile. Often, lightning bolts do not come in contact with the ground, but bridge the oppositely charged areas in the ground itself. Such bolts are sometimes completely hidden inside the cloud, and all that we can see is a bright flash known as sheet lightning. Sheet lightning is a very far off in the distance sheet lightning that is very far off in the distance is called heat lightning. Tornadoes. Deep within the largest and most powerful of thunderclouds churn the circular wind currents that are the makings of the most ferocious windstorm on Earth, the tornado. A tornado is produced by the powerful updraft of warm air sweeping up into the cloud. As the current of air rises, it is struck by high-level winds blowing through the cloud from different directions, causing the updraft to spiral as it ascends. The rotating winds spin faster and faster as they draw closer together. About half hour between the circular winds form. Deep in the heart of the cloud, a swirling mass of clouds appears at the cloud's base. Emerging from the swirling clouds, a ferociously rotating funnel descends to the earth. A fully developed tornado is a fearsome storm. The sight of a tornado grinding toward you, screaming with the roar of 100 jet airplanes, is the stuff that nightmares are made of. Although a tornado covers a much smaller area than a hurricane, or dust storm, or blizzard, no other storm can pack as much destructive power into a small space as the tornado can. The tornado's column of rapidly spinning winds surrounds the eye, a calm region of extremely low air pressure. Although the speeds of a tornado rotation cannot be precisely measured because the high winds would quickly destroy the measuring instruments. Meteorologists estimate that a tornado's winds may whirl around at anywhere from 50 to over 300 miles per hour. The weaker tornadoes cause only minor damage, lifting roofs off houses and stripping trees of their leaves. But a powerful tornado of maximum wind speeds demolishes everything in its path, leveling houses to rubble, breaking trees into matchsticks and tossing around heavy objects of many tons, such as railway cars, church steeples, and whole buildings, as if they were made of foam. Meteorologists issue a tornado watch for areas experiencing weather conditions that could produce a tornado, but are unable to predict when a tornado will form in a particular thunderstorm. If a tornado is spotted, the tornado watch is changed to a tornado warning. But often before the weathermen can revise their forecast, a tornado descends without warning, strikes suddenly and ferociously, and leaves just as quickly, lasting only about 15 to 20 minutes. Tornadoes often behave rather strangely. They may travel down a street, destroy the houses on one side, but leaving the houses on the other side undamaged. They may lift off the ground suddenly, sparing several structures, and then touch down again. They are powerfully destructive, sending boards through brick walls, sticking straws into trees, and taking human lives. But sometimes they are unusually gentle. In the past, people have been picked up and carried by tornadoes, and then dropped back to the ground uninjured. For one instance, a cupboard full of dishes was swept away by a tornado, and then set down again without a single dish broken. And this section of Science and You is just kind of explaining storm safety, and we won't read that together, but you can read it on your own. And we will move on. Let's see. Making the forecast of page 239. Making the forecast. Your weather instruments will tell you many things about the coming weather. For example, if the temperature remains steady and the humidity rises, or if the temperature falls and the humidity remains constant, it is likely that rain is on the way. Your barometer is also a useful forecasting tool, especially when its readings are associated with winds from certain directions. The chart given here tells what sort of weather can be expected from several different combinations of wind direction and barometric pressure. One of the most important weather indicators are the clouds themselves. The direction that clouds come from often give advanced warnings of the sort of weather you can expect from them. In general, clouds riding out of the south bring rain. Those out of the east bring severe weather, and those out of the west or north bring fair weather or overcast skies. Rain clouds such as stratus, nimbostratus, and cumulonimbus, however, bring precipitation no matter what direction they come from. Thunderstorms usually come out of the west or north. If you know what clouds to look for, you can learn to spot an approaching warm front long before the precipitation actually arrives. The first clouds you will see are the Mars tails, which are cirrus clouds. By themselves, these clouds do not indicate bad weather, but they can thicken into hazy cirrostratus clouds that cover the sky. It is likely that they are the first indicators of a warm front. Often, you will see the cirrocumulus mackerel sky along with the cirrus clouds. To remember the progression of a warm front clouds, keep this old weather saying in mind. Mars tails and mackerel skies make tall ships take in their sails. The thin cirrus clouds at the highest tip of the advancing slice of warm air usually arrive about 20 to 30 hours ahead of the precipitation itself. As the front moves in, the cirrostratus clouds thicken and draw nearer to the ground, turning into altostratus and sometimes altocumulus. Even lower stratus and nimbostratus clouds follow the altostratus, bringing precipitation with them. Unlike warm fronts, cold fronts give little or no advance warning of their arrival. Although warm front clouds may stretch many hundreds of miles in advance of bad weather, a cold front's clouds are located in much narrower band. A row of powerful cumulonimbus thunderheads builds up in front of the advancing cold air in what is called a squall line. Sometimes a cold front is preceded by particularly dark and ominous-looking stratocumulus clouds. But many times the first sign of a cold front are a blackness on the horizon and a crack of thunder. Although you may not be able to predict a cold front long in advance, there are some interesting weather phenomena that you can monitor at the front passes. Look for sudden shifts in the direction of the wind and rapid changes in barometric pressure. These provide you with a clue as to how long the bad weather is going to continue. Short notice, soon to pass. Long notice, long will last, is a good saying to remember. You can also learn to predict the likelihood of afternoon thunderstorms on a warm day. If cumulus clouds early in the day remain fairly flat or small, there is little chance of a thunderstorm developing. These cumulus clouds are a sign of fair weather, and this proverb teaches, if fleecy white clouds cover the heavenly way, no rain should mar your plans that day. But if cumulus clouds grow tall before much of the day has gone by, there is a good chance of thunderstorms later in the afternoon. In the morning, mountains. In the evening, fountains. And we'll stop there for our comprehension check.